Alright, so in this video, let's look at the MAC address and how their devices learn about the MAC addresses of the other device in the network, in the local area network, and the role of the MAC address in facilitating the communication inside the local area network. That's what our focus today is going to be. So for the demonstration, we have a small network, and I've labeled it as PC0, PC1, PC3 and PC4, and we also have two switches. Each switch has been connected with two PCs, and you have a link connecting the switch 1 to switch 2. Okay, so for the purpose of simplicity, the demonstration, I've already noted the MAC address of each of the PC here. So this is the MAC address of the first PC, and this is the MAC address of the second PC, and so on. All right. So when you try to ping from PC0, let's look at the first switch only. When you try to ping from PC0 to PC1, it is using ICMP protocol. ICMP stands for Internet Control Message Protocol. So when you try to ping, the requirement is this PC has to keep the source IP address and the destination IP address on the layer 3. Since this PC knows it wanted to go to PC1, it knows the layer 3 address. After placing the layer 3 address, which is source IP address and the destination IP address, on the second layer, the PC has to place the source MAC address, which is this MAC address, and the destination MAC address, which is here. But the problem is the PC0 or anything, the PC0 has to learn the MAC address of the destination device through a process called ARP. So if this PC, if the device does not know the MAC address of the destination, it will initiate ARP before continuing with ICMP. That's what we are going to see here. And another thing is, whenever a switch receives information from connected devices, it will keep on updating its MAC address table. So in this case, this the switch 1, whenever there's information transmitted from PC0 to the other device, as and when it receives, it's going to update the MAC address table of the switch. Okay. With this, I'm going to switch from. Let me show you currently what is the status. Open the PC0 and go to the command prompt and give the command ARP-A. This does not know the MAC address of any other device in the network. Okay. Similarly, if you open this the switch and you give the command show MAC address table, we just know about the MAC address of the second switch, the port 24. Okay, that's all it knows now. So I'm going to switch from the real time to the simulation mode here. Let me do a screen arrangement. Okay, right. So let me start a PDU. PDU stands for Protocol Data Unit. From this PC, you wanted to ping the PC1. Okay, so it has created an ICMP. Now, if you open the ICMP packet here, you can see the source IP address is 192.168.1.1, which is the IP address of the PC0, and the destination is 1.2, which is the IP address of the PC1. Now, after filling this information on the layer 3, this has to be this will be going to the layer 2, where it has to put the source MAC address in and the destination MAC address. Now the problem is PC0, as we have seen, does not know MAC address of any other device. See, look at the ARP-N, nothing, does not know. All right. So since it does not know the MAC address of the destination, MAC address of the destination is 1.2. It does not know, so it has initiated ARP. ARP stands for Address Resolution Protocol. Basically, it resolves IP address to MAC address. Because the PC0 knows it has to communicate with the IP address 192.168.1.2. So that destination IP address is going to be resolved into its MAC address. So ICMP is paused for the time being. It is initiated ARP. Open the ARP here. If you look at the ARP, on the layer 2 it says it has kept its own MAC address, which is ending with 7765, same as this one. But on the destination side, it has kept all FFFF, right? Meaning it is a ARP broadcast. Basically, this ARP says, is there any device on this network with this IP address 192.168.1.2? If there is anyone, please let me know. So this information is going to go through is going to be sent to all devices in the network. And who is going to respond? Only the device with IP address 1.2, which in this case PC1 is going to respond. PC3 and PC4 is going to drop it because it says I'm not the one with IP address 1.2, isn't it? So let's do this simulation step by step. Click on. Now the information has gone from PC0 to the switch. See what the switch will do. Let's open the switch and give the command show MAC address table. Now it says, okay, since it received information from PC0 through this port FA0/1, it says it has updated the MAC address table. Look at this. It says, okay, switch says I can reach the device with this MAC address through this 0/1, which is this port. This port, okay. Now, so since this is a ARP broadcast, as we have seen here, since it is a ARP broadcast, this is going to be transmitted to all other devices connected to the first switch. So it has gone through this one and it has gone to here and so on. Now from the switch 2, again it's going to be broadcast to other two devices which is connected. Both of them are going to drop it. This has been dropped. You can see an X mark, this is dropped. But PC1, since the IP address is 1.2, this is going to respond. That's why it has sent a response to the back to the switch. Now let's look at what is gone out from the PC1. So here is the PC1. And if you open here and you look at this, what is going to go out? It says, okay, my IP address is 1.2 and is going to send to 1 with a 7765. That means it is sending a reply to the ARP broadcast. It is sending the reply. That means it says I am the one with this packet, with this IP address. So when this information is received on the PC0, it will be learning about the MAC address of the PC1. Now another important information is, since there was a communication, since there was ARP broadcast from PC0 reached the PC1, if you open PC1 now, it must have updated its ARP cache. Let's look at this. ARP-A says this machine with this IP address, which is IP address of the PC0, and this is the MAC address, 1 ending with the 7765. Right? Now this will go back to the PC0. Now, moment it received, if you open this ARP-A, it has updated the ARP. It has updated ARP cache. Says, okay, this IP address is being resolved into this MAC address. You look at the MAC address, one ending with a 3C63. That is the MAC address for the PC1. Now the PC0 knows the MAC address of the PC1. Now look at this, ICMP proceed. So it has started with ICMP. Since it did not know the MAC address of the destination, it has gone through all this ARP process. After learning the MAC address of the destination, now the ICMP will continue. Open the ICMP here. Look at this. going out. Let's look at the OSP here. See, it has kept on the layer 2, it has kept the source MAC address, which is the MAC address of the PC0 ending with a 7765, and the destination MAC address, which is ending with a 3C663. So your ping, the ICMP, which was requested here, which is started here, now it will continue. So it has gone through all this ARP just to learn the MAC address of the destination. Okay, now ICMP will proceed and it will go to this particular PC, then it will reply back. It means the echo reply, echo request, and reply. The ping is now complete. Okay. All right. Now let's try to ping from the PC0 to PC3. What will happen? Does PC0 knows the PC3 MAC address? Open it here. ARP-A. No, it does not know. Again, it will start ARP broadcast. Let's try to look at this. So I'm going to delete the present simulation here. Okay. Take a new PDU, protocol data unit, place on PC0 and PC3 is the destination. Again, ICMP has been created here. ICMP has been created here. It's source IP address and destination IP address, but ICMP cannot proceed because it does not know the MAC address of the destination. So it has initiated ARP broadcast. Look at this. ARP broadcast. ARP broadcast here. It's happening here. See, source MAC address and the destination MAC address FFFFFF. So this will be going to the PC3. Let's look at this. Will it go to PC1? Of course, this is a broadcast. It's going to go to PC1 also. So this will drop, PC4 will drop, but PC3 will respond. Say this is dropped here. You can see a tick mark. Now the switch 2 will send it further. Now PC4 has dropped this, but PC3 will respond to this ARP broadcast. Because why it responds? Because PC3 know its IP address 1.3. Right? Now, if you open this ARP here, it's going to send this MAC address, okay, back to this one. Source is, this is what has been received, right? Inbound. This is what been received, source MAC address, and this is the source IP address, and this is the target, okay, and this is a broadcast. This is what received on the PC3. All right. Now this is going to go out. Now let's look at this. What happened to the switch 1? Show MAC address table here. It so far knows about 7765, which is the MAC address of this one, because this has come to here, right? ICMP broadcast, the ARP broadcast has come here, so it's updated. Machine with this MAC address, which is this one, is being mapped to 24. That means it is through this port. Through this port only, switch 2 can reach PC0 through this FA024. That's what it's been mapped here. All right. So this is going to go to the switch. Okay. Again, this is updated. If you send it again here, if you check it again here, it says okay, 1 ending with the B565, which is this one, it's been mapped to 0/2. So the switch will keep on updating its MAC address table as and when it receives information from the connected devices. So go further. all this is ARP. And now if you open this PC0, you can see ARP ARP-A, you can see 1.3, this is the MAC address. Now the ICMP will proceed. Okay, started ICMP, through the ARP process, learn the MAC address of the destination. If you open this, now you can see this. Yeah, now it is completing the layer 2 address, source and the destination. Source is sending with its own MAC address, and destination is P565, which is the MAC address for the PC3. Okay, now ICMP will proceed and go to the second switch. From the second switch, it is going to the PC3. So this is how the MAC address is being used in establishing the communication between the connected device in a local area network. I hope this is clear to you, right? If you have any question, you can get back to me during the class time. Thank you.